Okay, welcome back to section 8.3, and here's an example of where I'm going to use the substitution, the secant. Now let's look at this picture right here. Again, this is one from the book, and it says that if you have something of the form x squared minus a squared, that you're going to use the substitution x is equal to a secant theta. So that's what we're going to be about in the next few minutes. Let's look at this problem right here. 7dx 49x squared minus 9. Notice you have the function squared minus the constant squared. That's the key to knowing it is a substitution involving the secant. All right, so what is this thing squared right here, 49x squared? That is 7x. And since I have a 9 over here, square root of 9 is 3. So I'm going to set 7x equal to 3 times the secant of alpha. Okay, just like we said here, x is equal to a secant of theta. I'm using alpha, remember, as I said before. So this is the main substitution, and our triangle later on will be based on this substitution, okay? The secant of alpha is 7x then over 3. All right, so now what's x? X is 3/7 secant of alpha. And then what does that make dx? That makes dx equal to 3/7. And the derivative of the secant is the secant times the tangent, and then d alpha. So let's go to the next page knowing that we need to substitute everything here in terms of x, now in terms of alpha. So here's our original integrand. And remember, we had, let me go back to the previous page here for you for a minute. Remember, we need to substitute 7dx. So if I multiply both sides by 7 here, 7dx is 3 secant alpha tangent alpha, right here. And so that's what I have. 7dx is 3 secant alpha tangent alpha. And then in place of 49x squared, I have 9 secant squared alpha. And now to go from this side of the equal sign to this sign, this would be 9. And then times the quantity times the quantity secant squared alpha minus 1. Square root of 9 is 3. Secant squared alpha minus 1 is tangent squared alpha, and the square root of the tangent squared is the tangent. Okay? So the numerator stays the same as I go from this from the left-hand side to the right-hand side of this equal sign. But now as I go from here to here, the tangents cancel, the 3's cancel, and I have a relatively easy antiderivative I'll be working with, and that is the secant of alpha. All right, so if I have now the antiderivative of the secant of alpha, I know that it's the ln of the secant of alpha plus the tangent of alpha plus c. And now I go back to that triangle that I should have drawn when I set up my original identity. Okay, here's alpha. Okay, and remember the secant was 7x over 3. Which means that this side, the other leg of the right triangle, is the square root of 49x squared minus 9. Notice how that fits nicely into our original problem. So now I need the secant of alpha, which is 7x over 3. Here it is. I need the tangent of alpha, which is the square root of 49x squared minus 9 over 3, right here, plus c. And now this is very similar to what I said in the last video you just watched. Look. If I add these two fractions together, I'm going to get 7x plus this square root divided by 3. And then if I use the property of the ln's, it will be the ln of all of this minus the ln of 3. But the ln of 3 is just a constant, so that gets folded into this capital C here, which we always say is an arbitrary constant. So our answer now is the ln of this absolute value plus c. Okay? So I hope this helps now with a second problem in this section, and that was the substitution that deals with secant. Bye for now.